The best way to learn multiple choice questions for physics is to do lots of them. Grab a pen and paper and solve some multiple choice questions with me. Please note that I've seen many of these questions before because this is the spec that I teach. However, if I do any mistakes, I will leave them in the video. No, I've made a mistake on this question. I really wanted to get all of them right. And then I'll talk you over any mistakes that I did because I believe this is probably more valuable to you learning and might highlight some more common mistakes. Calculator ready, and let's look into question 1. Which of the following could be the wavelength of ultraviolet radiation? Okay, so what I remember is that visible light is somewhere between 400 and 700 nanometers. So this is between 400, this is between 4 times 10 to the power of -7. And UV has a smaller wavelength, so the answer has to be something which is smaller than 4 times 10 to the power -7. So it's not going to be this. This is an X-ray, 4 times 10 to the power of 2, way too big. Correct answer has to be D. K2, which term is not used in either of the Kirchoff's 2 laws? So Kirchoff's first law says that the sum of the currents entering a junction is equal to the sum of the currents exiting a junction, and it's to do with currents rather than charge per se in the actual term. So I'm going to go with A, charge. Current is definitely used. EMF and potential difference are used in Kirchoff's second law. The sum of the EMFs is equal to the sum of the PDs in a closed loop. Okay, question 3. The diagram shows the refraction of light at the boundary between 2 transparent materials, X and Y. The refractive material of X is 1.5 and the refractive materials of Y is N. Which of the following expressions is correct? Okay, so we're going this way and then we're refracting towards the normal, it seems. So the refractive index of X is 1.5, so I'm going to go N1, 1.5, sine theta 1, which is the angle towards the normal. This here is my angle of incidence, which is going to be 90, take away 20, which is just going to be 70. Sine of 70 is equal to N2, which in this case is N. And then we're given the correct angle here, which is sine of 50. And I think this here is the correct expression. 1.5 sine of 70 is equal to N sine of 50. This seems to correspond to correct answer C. Sometimes there is a trick with those questions. I think it might be the angle trick in this case. Okay, let's move on. Question 4. A student is carrying out the double slit experiment using visible light. Distance between the slits and the screen is kept constant. The wavelength of light is lambda and separation of the slits is A, and we have some results. Which combination of A, lambda and A will give the largest separation between adjacent bright fringes? Okay, there's quite a lot of information in this multiple choice question. So what I'm going to do is just write out my equation, which is that lambda is equal to AX over D. Now, A in this case is the slit separation, X is the fringe separation, and that's what we're looking for. So I'm going to say that X is lambda D and then divided by A. Which combination of lambda and A will give the largest separation? So basically we want the ratio of lambda and A to be the largest. Okay, and this distance here is kept constant. So I think all I need to do is just calculate 1, 2, 3, 4 of these, and let's see which one will give me the largest. So first one, 450 over 0.2. This will give me 2250. Okay, next one, 510 over 0.15. This one here will give me 3400. So far this one is winning 550 over 0.25. 2200. Probably there's an easier way of doing it, but I'm kind of stuck with this way now. 610 over 0.30. Okay, this one is 233. We seem to have a winner, and that is indeed B. Okay, let's move on to the next one. We have a car of mass 1000 kg and is traveling on a straight and horizontal road. The driver applies the brakes. Okay, the speed of the car decelerates from 20 to 15 meters per second in 2.4 seconds. What is the average power dissipated by the brakes? Okay, so power is equal to the change of energy per unit time, which is going to equal to a half m, let's say v2 squared, take away half m v1 squared, basically the change in kinetic energy, divided by delta T, which in this case is 2.4. Now I can probably just put those into my calculator. I could have found the difference the other way, because this will give me a negative sign otherwise, but let me just put those into the calculator. In the real exam, I would recommend not wasting too much time kind of writing everything out, but just using your calculator quite a lot. Okay, so I'm going to go 0.5 multiplied by the mass of the car, which is 1000. Multiplied by 20 squared, take away 0.5 times 1000 times by 15 squared, and this here will give me 3.6 times 10 to the power 4. Correct answer is C, I think. Okay, let's move on. Question 6. So we've got two coherent waves are emitted from the sources X and Y. The diagram is not up to scale, so that means we can't take any measurements with a ruler. The waves at X and Y are in phase. The waves have a wavelength of 4 centimeters. The phase difference of the two waves meeting at a point P is 270. Which rho gives the possible distances for A and B? Okay, so if they meet at P with a phase difference of 270, given that the whole cycle is 360, let's just calculate that fraction, which will be 270 over 360. And this here will just give me 3 over 4. So this means that the path difference as well should be in that ratio of 3 to 4. So let's have a look. A and B should be in that ratio. So 20 to 26, what will that give me? That will not give me that. 22 as well. Okay, it actually took me a moment to spot this question, but obviously their phase difference is 270 over 360. Now this means that their difference in wavelength will have to be 3/4 of an entire wavelength, which is 4 centimeters, which is of course just going to be 3 centimeters. Now this has to be the difference between the two waves, and out of those the only two options that I see that differ by that amount is option C, so I'm gonna go for this as the correct answer. Okay, question 7. A resistor of resistance 12 ohms is connected in parallel with another resistance of resistance R. The total resistance of the circuit is 4. What is the value of R? Okay, so I'm gonna go 1 over 12 plus 1 over R raised to a power of minus 1 is equal to 4.0. Okay, well, let's just do a little bit of algebra. So let's just flip everything. So I'm going to go 1 over 12 plus 1 over R is equal to 1 over 4, and then we're gonna go 1 over R is equal to 1 over 4, take away 1 over 12. This question is way easier with a calculator. So 1 over 4 take away 1 over 12, this will give me 1 over 6, and then we're going to flip it, giving me 6 ohms. Correct answer is B. Okay, next one, we have a cell of an EMF of 1.2 volts is connected to a wire of resistance 6 ohms. The potential difference across the wire is 0.90 volts. So what is the internal resistance of the cell? Okay, so let's see what we can do here. We can use the fact that E is equal to V plus IR, for instance. We know what V is, we know what the EMF is, but we don't really know the current yet to be able to figure it out. Let's see, what will be a good way of attempting this? Well, we can figure out the current from here. So I'm just going to say V is equal to IR, and 0.9 is equal to IR. So I will be 0.90 divided by 6.0. Oops. Which is just going to be 0.15 amps, like that. Now we've got the current in the circuit. We can directly use this expression to determine the internal resistance, or actually even easier, if we know the current, then the amount of lost volts is 1.2 take away 0.9, which is 0.30 is equal to I times R, meaning that R will be 0.3 divided by 0.15. Correct answer has got to be C, like so. Okay, next one, a thin metal plate is free to rotate in the vertical plane about the point P. 4 forces A, B, C, and D act at the same point on the plate as shown. The diagram above is drawn to scale. All the forces are in the vertical plane. The forces have the same magnitude but act in different direction. Which force will produce the greatest moment about P? Okay, so all we need to do is look at the force times its perpendicular distance. All forces have the same magnitude, so we just need to compare their direction. Okay, So it's not going to be C because that has no perpendicular distance from P to the line of action of the force. Question is, which one will have the largest perpendicular distance? So the perpendicular distance from P to the line of action of this force here is sort of like this much. The diagram is drawn to scale. Hopefully I don't have to use a ruler. Hopefully it'll be pretty obvious. The perpendicular distance from P such that there is a 90-degree angle will be looking something like this for this one. So probably not going to be that, not excessively larger. What about B? Let's have a look. What is the perpendicular distance from... I'll need a ruler for this one. If we were to extend B like that, okay, it's not going to be B because that distance is not very big. Question is it going to be A, which is sort of about this big, or is it going to be B, which is, or is it going to be D, which is this perpendicular distance? We've not really drawn A, have we? So let's kind of like extend A. Oh gosh, this digital whiteboard is terrible. Please do that properly in the exams. I think it will actually be A because this distance just kind of like visually looks like the greatest. This looks like a work of modern art, but I'm gonna go for A on this one. Okay, question 10. We have a total of 3.8 times 10 to the power of 7 electrons flow through a wire in a time of 1.2 microseconds. What is the current in the wire? Okay, so for this one, all I need to do is multiply. So the current is going to equal to delta Q over delta T. So that's going to be NE over delta T, which is 3.8 times 10 to the power of 7, each of them 1.6 times 10 to the power minus 19. The real example, please just do that in your calculator. Divide that by 1.2 times 10 to the power of minus 6. Okay, let's see what we get. 3.8 times 10 to the power of 7 times by 1.6 times by 10 to the power of minus 19 over 1.2 times 10 to the power of minus 6. And this here is going to give me a tiny current. So 1, 2, 3, 4, 5, 6, around 5.1 times 10 to the power of minus 6. I'm going to go for correct answer C. Okay, 11. An electric motor is used to lift a weight of 4 newtons for a vertical height of 0.9 meters in 1.8 seconds. The efficiency of the motor is 20%. What is the electrical power supplied to the motor? Okay, so 20%, the percentage efficiency is going to be useful over the total power. The total power, the useful power is mGh. The total power is, well, that's going to be VI times T. Let's just compare energies. So I'm going to say, well, energy here. Should we just call it energy? And you can think of this in terms of power division by time, but the factors will just end up cancelling each other. So this should be straightforward. Okay, multiplied by 100. So okay, we've got the weight, we've got the height. We can just work out the energy and then we can work out the power through there. So the energy will just be mGh times 100 divided by 20. which will then be equal to 4 times 0.9, then 100 over 20, not 200, spotted that mistake. So multiply by 5, that will just give me the energy. So 4 times 0.90 multiplied by 5 is 18, and that happens in 1.8 seconds. So the power should just be 10 watts. Correct answer is D. Okay, plane polarizing light is incident perpendicular to a vertical polarizing filter. The polarizing filter is rotated about the horizontal axis. What property of the transmitted light changes as the filter is rotated? So definitely the intensity of the light will change. Okay, 13, we have a load that is suspended from 2 wires P and Q as shown. And okay, these questions normally take quite a lot of time. We've got the Young's modulus. Okay, what is the extension of the wire Q? Okay, so we've got the original length of the wire is L, Young's modulus is E, and then the extension of this wire is a 4.0. Well, Young's modulus is just going to be the amount of stress, divide that by the amount of strain, which is just going to be for the original wire. They both have the same force, don't they? So I'm just going to call that F. Okay, what about the diameter? Both wires have the same diameter. Okay, so they have the same stress. Okay, so if they have the same force and the same stress, I can just leave that in terms of the actual stress. So I'm going to say stress multiplied by the original length and then divided by x. Where did that come from? Because the strain is just x over L. Well, this here will equal to the stress times L divided by x. Okay, so the extension of the first wire is just 4, so we can just say that, let's just rearrange for x, and this is equal to rho times L, and then divide that by E. Okay, so if E increases by 3, then x should decrease by 3. Now the stress is pretty much unchanged, but the length has increased by a factor of 1.5, which means that x will also increase by the same factor. So the extension will be 4.0 times by 1.5, but then divide that by 30, giving me an extension of 2.0 millimeters. Correct answer should be A, hopefully. Okay, next one. Which graph best represents the way in which the resistance R of a negative temperature coefficient NTC thermistor depends on its temperature? Okay, so this is an easier question finally. Correct answer is A. The resistance kind of like decreases like so. Question 15. A student balances a uniform metal rod horizontally. Here is the setup. The rod is pivoted at its middle. The position of the weight W is kept constant. The distance of the weight F from its pivot is X. The student changes F and then adjusts so that the rod remains balanced. Okay, which statement is correct? Before I even read the statements, I'm going to know that F times X, this is the moment due to the force, has to be equal to W multiplied by sort of whatever distance here this is. We'll just call that D for the time being. Okay, now a graph of f against x will be a straight line through the origin. This is interesting. A graph of f against x, okay, will be a straight line for the origin. I disagree with that because f will be wd times 1 over x. So unless there is a dependency of d on x, it should not be a straight line. The upward force at the pivot is equal to f. Okay, is this correct? Well, the total upward force will have to balance the downwards force. Seems potentially right, actually. Uniform metal rod. Oh well, no, it cannot be right, obviously, because it's going to be equal to F plus W. I forgot about W temporarily, so these two will not be correct. The weight of W is equal to Fx. The weight of W, this doesn't seem dimensionally correct, because the weight cannot equal force times distance. So I guess the correct answer has to be D. Let's see though. X is inversely proportional to F. That seems right, well, because of this equation here, assuming those things don't move. So yeah, I'm gonna go for D. Okay, next one, we've got IV characteristics of two components are now shown. Which statement is correct? Okay, I against V. R and L are both filament lamps. Nope, that is not true. So the shape of a filament lamp is like this, with the resistance increasing with the current and the temperature. R and L have the same resistance at 1.5 volts. Okay, 1.5 volts. I presume it's this point here. Hang on. Middle point is there. I need a ruler. Okay, so we're gonna need to calculate this, I'm afraid. So resistance is V over I. So they cross at that point, meaning that they're gonna have the same resistance and they are gonna have the same current as well. So that seems correct. The resistance of L is independent of the potential difference V. Nope, that's generally not correct. You can see that the resistance, which is the inverse of the gradient, varies. The resistance of R increases as the potential difference V increases. And that's pretty much a straight line through the origin, isn't it? So that's not correct. Yeah, I'm gonna go for B. K7, the photoelectric effect can be demonstrated using a gold leaf electroscope. The zinc plate is negatively charged. Ultraviolet radiation on the zinc collapses the gold leaf. What is removed from the zinc plate by the incident radiation? Nicely done. It's electrons. This one is a lot easier than the rest. 18. What is the total energy gained by n electrons traveling through a potential difference V? Okay, well, energy is equal to EV, so for n electrons, total energy should be NeV. E is 1.6 times 10 to the power of minus 19. Seems like correct answer has got to be D, so that's NVE, like that. 19, a student is experimenting with sound waves of wavelength 3 centimeter and an electromagnetic waves also of 3 centimeters. Which statement is correct about both of these waves? Okay, so sound waves can't be polarized, so that's not the case. They can form stationary waves. They can both form stationary waves, so B is correct. They have the same frequency and they have the same speed. That is definitely not correct, and this one here is not correct. I'm gonna go for B. Okay, next one here, last one. A laser emits a uniform beam of light. Which two quantities are required to calculate the intensity of the beam of light? Okay, well, intensity is the amount of power over the cross-sectional area. So, well, B seems like a perfectly reasonable answer. Which two quantities alone are required? Let's just check for a little trick. I don't want to do a mistake right at the end. Energy and time. Well, we still need the area for the actual intensity for the beam of light. Frequency and wavelength. Yeah, I'm just gonna go for B. So my first set of questions, after having marked them, they're all correct so far. Yes. Okay, let's move on to the next paper. So this is now questions from Modeling Physics from 2022. A student has constructed the table below for scalar and vector quantities. Which row is correct? Acceleration is not a scalar, it's a vector. First one is not correct. Displacement is a vector as well. Wavelength is not a vector. The mass is indeed a scalar, and the centripetal force is a vector. Correct answer is D. Okay, question 2. The diameter of the wire is measured in 5 different places along its length. Which row is the absolute uncertainty in the wire? So the way we do these questions is by looking at the range. So the absolute uncertainty is equal to half of the range. The range is the largest value, take away the smallest value, divided by 2. Now my largest value seems to be 1.92 millimeters. Then smallest one seems to be 1.86, and then we're just going to divide that by 2 like so, and we should get 0.03 millimeters. Correct answer is B. Okay, let's move on. A student has plotted a graph. Has plotted a velocity against time graph for a trolley moving down a ramp. Which of the following quantities can be determined from the gradient of the graph in the area? Okay, so it's a VT graph. Before I even answer this question, I'm going to see what the gradient is. So V over T, that's just my acceleration, and the area V times T, well, that's just equal to the displacement. I know it's actually the integral or that, but basically this times that will gives me units of displacement. So acceleration, displacement, there we go. Correct answer is A. Okay, so far I feel that the A2 questions actually seem easier than the ones that I did before. The diagram below shows the direction and magnitude of 3 forces acting on an object at specific times it moves through water. The weight of the object is 1.2 newtons, the upthrust on the object is 0.8, and the drag is 0.6. Which statement is correct about the object at this specific time? Okay, so there's going to be an upward force of 1.40 newtons and a downward force of 1.20 newtons. This means that there will be a resultant upward force of 0.2 newtons. If there is a resultant upward force, there has to be an acceleration. It's not reached its terminal velocity. It is accelerating. Hang on, is it, or it could be decelerating. Which direction is it actually moving? Oh, the drag is 0.6. Okay, so if the drag is 0.6, this means that the object is moving this way downwards, but the net force is the other way, so it has to be well, decelerating, meaning that it's slowing down because it's moving this way, but the net force is this way, meaning that the acceleration is upwards. Okay, correct answer is C. Okay, question 5. The object below is in equilibrium. A force not shown in the diagram also acts on the object at P. Which of the following shows the correct direction and magnitude of the force acting at P? Okay, so we need to do two things. We need to balance out the magnitude of the individual forces in every direction, and pretty much the only way that we can do that is if we have a force of 5 newtons or 5.6 acting this way. This way the moments will be balanced, but also the vertical and horizontal components of the forces will be balanced. So I'm gonna go for B, the correct answer. So far so good with those questions. Okay, 6. A particle of mass collides with a stationary particle of mass 4m. I've recently solved this question actually. A student asked me how to solve this question. Let's see if I remember how to do it. The mass is hitting another mass of 4m, so the total momentum in the y direction is not is 0, so that means that the total y momentum after the collision has to be 0 as well. So the y component of the velocity is v1 sine of 60. The angle is 60, isn't it? Yeah, it is 60. X has a mass of 4m, and that has to be equal to the total y component in the y direction for particle y. So this angle here is 90 degrees, this one is 60, so this one here has got to be 30, shouldn't it? So this here will be m sine of 30. Okay, we can cancel out the m's, and we also forgot to multiply this by v2. Oh, hang on, I can't write here. Let's try again. I'm going to put the v2 here. Okay, so that's m sine 30 times by v2, or kind of v2 times m sine of 30. So what we're left with, if I was to rearrange for v1 over v2, I should get sine of 30, which is a half, divide that by 4 sine of 60. Let's put that into a calculator. So sine of 30 divided by 4 sine of 60, root 3 over 12, 0. Hang on, I've done a mistake here. It's actually really funny because I was probably most confident on this question because I literally solved this a couple of days ago, but I got an answer which is not actually on here on the mark scheme. Now, I think I've spotted what I've done. So particle X has a mass of m, so the factor of 4 shouldn't be there. Let's get rid of this factor of 4, but the factor of 4 should be on this side. Let me just write the other side properly. So this thing is equal to 4 because particle Y has that mass 4m, which will get cancelled, and then we have V2 sine of 60. Now this here will move our factor of 4 up here, and what we should get, let's try this. So we get 2.3. Correct answer is A. This is really interesting actually, because I did the mistake, the question I was most confident on. So if you're feeling really confident at a particular question, it's still worth just looking for a trick or just watching out for a little silly mistake. Okay, next question. We have a metal block of mass m is heated by an electrical heater. The graph of the temperature theta against time for this block is shown below. The power of the heater is P, the gradient of the straight line graph is G. What is the correct expression for the specific heat of the metal? Okay, so energy is equal to mc delta theta. Energy is power times time, because power is energy over time. So if we arrange that, we get that, which is equal to mc delta theta. Power is equal to mc delta theta divided by time, but this quantity here is my gradient. So if this here is my gradient, I'm just going to call that grad, which is going to be equal to the power divided by mc, where c is the specific heat capacity. Oh wait, hang on, we're trying to rearrange for the specific heat capacity, not for the gradient. So c will be the power divided by m grad. Okay, gradient, they've just called it g, so correct answer should be D, P over M times by the gradient. Okay, next one. Which statement below are implied by the assumptions of the kinetic theory of the model of gases? Now they've used the word implied, so I'm just going to be a little bit careful here. A gas is mostly empty space. Yes, this is implied. There's a statement for the comparison of the volume of the container compared to the volume of the particles. So the volume of the particles is negligible compared to the volume of the container. This means that a gas contains a lot of empty space. Gas particles spend more time between collisions than time during collisions. Yep, that's also true. There are always forces between the gas particles. The answer is no. We only take into account the forces during collision. So 1 and 2, correct answer is A. Okay, question 9. A container has 1 mole of gas at a pressure of 100 kilopascals. Root mean square speed of the gas particles is 500 meters per second. The mass of each gas particle is 4.7 times 10 to the power of minus 26. What is the volume of the container? Now, we've got a formula for this in the formula booklet. So if we go on to module 5, and then thermal physics, which is just here. This is probably the formula that we are going to use in this case. So I'm just going to write it here, and the formula will be PV is equal to 1 over 3 NM C squared. Now let's just make sure that we got the formula right. NMC squared. Okay, let's also be careful with the dashes. So it was a square and then the dash was on top. Okay, cool. So what is the volume of the container? So V will be 1/3 NMC squared and then divided by P. Okay, I think I've got pretty much all of these. Now I'm just going to put those straight into the calculator. your n, the number of particles for a mole, will just be equal to Avogadro's number, so around 6 times 10 to the power of 23. We're given the mass of each gas particle. Okay, we don't have to calculate that, so that's nice and easy. 4.7 times 10 to the power of minus 26. Then we need to multiply this by the root mean square speed, which is 500 meters per second, careful with the units, squared, and then divided by 100 times 10 to the power of 3. And this here should give me, let's have a look, and then multiply by a third as well. Okay, times by 3. So I get around 2.4 times 10 to the power of minus 2. Correct answer is C. The actual fraction I got was 0.0235. Okay, next one, question 10. A mass is attached at the bottom end of a spring which is fixed at the top end. Okay, so here's a spring, you put a mass on top, kind of a standard particle. The mass oscillates with simple harmonic motion. Which row correctly describes the energy of the spring mass system when the mass is at its lowest point in the oscillations? Okay, so its equilibrium is kind of like here, and the mass will have some elastic potential energy because it will want to go back to its equilibrium, but also it will have some minimum amount of gravitational potential energy, and right at the moment of maximum amplitude, its speed will be 0, so I know that the kinetic energy will be 0. Okay, so it's either going to be B or C, and the gravitational potential energy is at a minimum, so elastic potential energy is at a maximum. Correct answer has to be B. Okay, which pair of quantities do not have the same or equivalent units? Okay, acceleration and gravitational field strength, they have the same units, angular frequency and angular velocity, s to the power of minus 1, gravitational potential and kinetic energy, absolutely not. This is in joules, the kinetic energy, the potential is in joules per kilogram, so correct answer is C, they do not have the same units. Okay, question 12. The diagram shows 3 levels, X, Y, and Z, just like in Z physics, of an electron within a gas atom. Which transition is correct when the electron absorbs a photon with the shortest wavelength? Okay, so the energy of a photon is hc over lambda. The shortest wavelength will correspond to the maximum energy. So we're going to want this to be as large as possible, the energy. And when we absorb a photon, we're going up in energy. So my guess, before even reading the answers, is going to be Z to X. So let's go for that one. A, just a little check, absorbing, so it will have to go up in energy. Okay, next one, light from a hydrogen source is incident normally at a diffraction grating. The first order diffraction, we've got the wavelength, it is observed at an angle of 30 degrees. Okay, I have a feeling this will be a good calculation question. So light from a hydrogen source, it's incident normally at diffraction grating. The first order, okay, so I'm going to write d sine theta is equal to n times lambda, is observed at an angle of 30 degrees. So we know the angle, don't we? Yep, we know the angle, we know the wavelength, and we know the order, so I can say that d will be equal to n lambda over sine theta. Okay, let's work that one out. So first order is it? Yep, lambda is 4.86 times 10 to the power of minus 9. I think this is going to be quite a long calculation question, so I'm just going to do, I'm going to actually write these things here so I can come back later and check it if I need to. Okay, so 486 times 10 to the power of minus 9 over sine of 30, which is just a half. Okay, this here will just give me 9.72 times 10 to the power of minus 7 for the line separation. Okay, light from a distant recording star is observed with the same diffraction grating, meaning that this quantity d will be the same. Okay, the speed of this star is 0.16 c, where c is the speed of light. What is the observed angle of the first order maximum of the H spectral line from the light of the receding star? Okay, so I have a feeling we'll probably have to use a distant receding star. So I'm going to use the Doppler effect equation, and that is that delta lambda over lambda is equal to V over C. Okay, so gosh, this is kind of a long question. So delta lambda, my change in wavelength, will be V over C, which is 0.16 C over C, multiplied by the original wavelength. So the wavelength will change by 0.16 times by 486 times by 10 to the power of minus 9, which is 7.776 times 10 to the power of minus 8 meters. So this means that my new wavelength, let's call that lambda 2, will be 486 times by 10 to the power of minus 9, take away 7.776 times 10 to the power of minus 8. What does that give me? Around 400 nanometers, 4.08 times 10 to the power of minus 7 meters. Okay, so that's the new wavelength after the Doppler shift. And now we have to apply d sine theta is equal to n lambda again to figure out the first order. So I'm going to take this equation and then I'm just going to say sine of theta is equal to is equal to n lambda divided by d, which is going to be equal to 1 times for the wavelength, I'm going to write 4.08 times by 10 to the power of minus 7. Let's divide that by the distance, by the line separation, d 9.72 times by 10 to the power of minus 7. Okay, and then let's remember to take the inverse sine of this. So 4.08 times by 10 to the power of minus 7 over 9.72. I really hope this is an answer because this is turning into quite a lot of work already. Okay, I've taken the inverse sine and I get around 24.8. I hope the answer is A. No, I've made a mistake on this question. I really wanted to get all of them right, but yeah, I've got a little silly mistake here. So let me just show you what I did because I think this will be really useful for your learning. So my mistake is right over here when calculating the new wavelength. So the new star is actually receding, meaning the new wavelength will of course be longer. So this means that lambda 2 will be this number, 7.776 times by 10 to the power of minus 8 plus 486 nanometers times 10 to the power minus 9. Now this is going to change this number to 5.6376 times 10 to the power of minus 7. So let's see what we get. Inverse sine of fraction 5.6376 times by 10 to the power of minus 7 divided by 9.72 times by 10 to the power of minus 7. Okay, and we are going to get 35.5. Correct answer is D. And that was my only mistake. Question 14. A galaxy this many light years away from the Earth has a recession speed of 23 kilometers per second. Which expression based on the information above is correct for the age of the universe? Okay, well, we can calculate its speed, Hubble's constant from this speed. So I'm going to use V is equal to H naught multiplied by D. Okay, so H naught will be V over D, which is 23 kilometers per second. Then we're going to be dividing that by the amount of light years, which I'm going to need to convert to seconds. So this is 10 to the 9 light years. Now let's see if we're given the amount of light years, because this will make our job a little bit easier. I have a feeling that we're actually given this. There we go. A light year is 9.5 times 10 to the power of 15. So times by 9.5 times 10 to the power of 15. This is 23,000 kilometers per second, so that's times by 10 to the power 3. Okay, now the age will be 1 over that value, which is going to be 10 to the 9 times 9.5 times 10 to the power 15 divided by 23 times by 23,000 times 10 to the power 3. Let's write it like this. Okay, so which answer will this correspond to? 1 times 10 to the 9, 9.5 times 10 to the power 15. Yep, correct answer appears to be C, as we can see. Okay, final one from this paper. Astronomers observe approximately the same number of distant galaxies per unit volume in all directions. So same amount of stuff per unit volume. Which idea does this observation support? Well, that supports the cosmological principle, which is B, that the universe is both isotropic and homogeneous. Isotropic meaning that it appears the same in every direction, and homogeneous meaning that it has roughly the same matter density distribution across the universe. So after having marked the questions, all of the other ones were correct except for question 13, which we've gone over. So one mistake. Unfortunately, after you finish your multiple choice workout, there is yet another incredibly crucial skills that you must be able to do before physics exams. And this is precisely why you should have a look at this video right over here that will go over such a question.